Hello guys, this is Jinesh and today we are going to discuss about sound. Why sound is because I'm doing my final year thesis on sound, how it propagates, and I'm going to model sound in different medias. So basically, sound when you search it in internet, there are different definitions that are available. So basically, I have some different definition. Maybe it is very similar to internet, but whatever I have understood, I'll try to put it in definition. So sound is nothing but a pressure wave that is sensed by a human ear or any microphone, or you can say the vibration of the molecules in air, and that is sensed by a microphone. I'll tell you why microphone exactly, because we have a particular hearing range. So we can hear in between 20 hertz to 20,000 hertz, while microphone doesn't have that kind of thing. It can hear from from starting from 0 to some kilohertz, some maybe 200 kilohertz or something like that. It depends on the sampling rate that will be covered afterwards, because it involves some mathematical terms and how fast you take the readings of that pressure fluctuation. So basically, when you say what is sound, sound is nothing but a pressure fluctuation because of some different forces available, or maybe because of some bomb exploding, or when I'm talking, my vocal cord is vibrating at particular frequency and you're hearing me, right? Now, let's consider a sphere that is expanding and contracting at particular frequency, let's say 20 hertz. And that not 20 hertz, let's say in hearing range, let's say it is 100, it is vibrating at 100 hertz. So now when it vibrates at 100 hertz, the air molecule beside near to the sphere will also vibrate at 100 hertz. So that vibration will be transferred to next next molecules. So that is how it propagates. It is kind of a domino effect. You might have heard about domino, or you know what is domino is, right? Or you can search it on internet, what is domino. So these are kind of some tiles, some rectangle tiles. When you put it, and when you push one tile, all the tiles will fall due to this domino effect. So this is how sound propagates. Whatever I'm talking, my my vocal cord is vibrating at particular frequency. That because of that, air is also vibrating at particular frequency because of my vocal cord, and this is basically transmitting to the microphone. And this microphone in turn senses it, and this is basically a uh, mathematically intense thing. So it stores, or maybe it directly converts it into ones and zeros, and stores it into memory card, or directly transmit via internet to other person. And that message is then again decoded in your computer or maybe cell phones. And then again it vibrates, again the speaker vibrates at particular frequency and a particular intensity, so that you can hear that. This is when you understand it, when you understand the basic, you can easily grasp all the things. So let us see what sound is, right? Because sound, many people think like this is particle. Suppose that there is a particle in a space, and some people thinks that when we talk, or when sound propagates, it's particle will propagate. But this is not the truth, because particle will vibrate at particular at a place. It will vibrate at a particular frequency, and that in turn give its energy to the next particle, and that is how it propagates. That is how the sound propagates, but not the particle. So we can say it as a wave. So it is a wave, right? It vibrates at particular frequency, and this in turn propagates sound. And sound has a constant value. It also depends on the temperature, I know. But when you see on the sea level, in air, on the sea level, the standard is 400 sorry, I'm sorry, that is 342 meters per second. So the speed of sound will be 342 meters per second. So it travels at the speed of 342 meters per second, or around, I don't know, maybe you can convert it into kilometer per hour. um, so yeah, this is the basic of sound. And when we look into mathematical manner, it becomes a bit complex. But when you understand the mathematical thing, you'll actually appreciate how mathematics and physics, they both come together and show some beautiful things about sound. And that is what I'm going to cover in coming videos. Maybe I'm going to derive some equations. Don't worry about it, these will be very simple equations. And using these equations, I will try to explain how sound propagates, why that is needed, I mean, why this formula is built like that, and what exactly that we need from sound, so that it can propagate efficiently. That is all for this video, and maybe I'm not going to cover formulas. In next video, I will try to cover some basics, like what are the basic measurement that we do in sound, what are the units of sound. uh, that's all, I mean, I'll start from that and maybe propagate in that particular manner. And I'll try to cover all the mathematical aspects as well as theoretical aspects, so that you can understand very well. And I will try to make some mathematical model, and I will try to explain how it works. But that is for future, and I'm not pretty sure that I will be going to make my own model. But still, let's hope that I can make my own model after, I'm sorry, before completing my thesis. So yeah, thank you.